Welcome to ET322, the how-to video for the Diode Homework. Here's our first problem, number 1, and if you look at that, the diode is in backwards, which means it's reverse bias, which means it actually doesn't be part of the circuit. So our voltage is going to be the full 6 volts. And if it doesn't make sense, that's because the current is going through our meter. The circuit's not connected to ground, it's actually going through our meter. Okay, I have my trusty calculator here, my TI-30X2S, and let's go ahead and figure this out. In the instructions, which may not be on this copy, that diode is going to be 0.7 volts. So we have 6 volts minus 0.7, which is our diode loss, is 5.3 volts. So Ohm's law equals I equals V over R. So we got 5.3 divided by 8K. And we have 5.3 divided by 8,000, and we got 625 point, wait a minute, nope, 662.5 times 10 to the minus 6, which is microamps. Okay, and that would be the total current, and resistor VR1 would be this 5.3 volts. Okay, we need to find the voltage across the Zener diode. Since the Zener diode is reverse bias, it's going to have the Zener voltage. So our Zener voltage is going to be 2 volts based on our instructions. All right, so our diode voltage is going to be 10 volts, or excuse me, our resistor voltage 10 volts minus 10 volts, 2 volts equals 8 volts. So 8 volts divided by 8K, I equals V over R. We are going to get 1 milliamp. Okay, we need to figure out what the voltage across our Zener is. Since it is forward biased, because the arrow is pointing towards ground, it's going to be the 0.7 volt diode voltage. It's going to act like a diode. So 10 volts minus 0.7 volts, 9.3 volts. 9.3 volts divided by 8K ohms. I equals V over R. And our calculator says 9.3 divided by 8,000. It's going to be 1.6 milliamps. 1.16, sorry. Okay, it is asking us which of the LEDs will light. We're going to look at the LED which is forward bias, which would be LED 1. So LED 1 would be the one that's lit. The other LED is reverse biased, so it won't light. Okay, here they're asking for the voltage across the LED. Since it is forward biased, it is operating at the 1.5, so the VLED equals 1.5 volts, which is reasonable for an LED. So our voltage is 8 volts minus 1.5 volts equals 6.5, and V equals R over R. I equals V over R equals 6.5 over 1K equals 6.5 milliamps. Reasonable. Okay, let's do problem 7. What we have here is a Zener diode, which is reverse biased in parallel with a 1K resistor, which means our Zener voltage is going to lock in the voltage of this parallel. So since our Zener voltage is 3 volts, VR2 is also going to be 3 volts. Okay, so VR1 is going to equal 8 volts minus 3 volts equals 5 volts. Okay, and we have I equals V over R. 5 volts divided by 1K ohm equals 5 milliamps. And I think that's all. Okay, we have a circuit here with 2 diodes in. Since they're both forward biased because they're pointing towards ground, this guy is going to be 0.7 volts. This guy is going to be 0.7. So 2 times 1.7 equals, 0.7 equals 1.4. Our total voltage is going to be the battery. 8 volts minus 1.4 volts equals 6.6 volts. Alright, so I equals V over R, and we have 6.6 volts divided by 10K ohms. And let's put that in the calculator, make sure I get the right answer. So we have 6.6 divided by 10,000. And we got 660 microvolts. Excuse me, microamps, which is 10 to the minus 6. Okay, we have a problem here similar to the last one. So we have 2 diodes, 0.7, 0.7, 2 times 0.7, 1.4, 2 series diodes, so we have 8K plus 2K equals 10K ohms. Okay, and so we have 1.4 volts, or total voltage of 12 volts minus 1.4 equals 10.6. And our resistance is 10K. So let's go ahead. We have I V over R. So we have 10.6 volts divided by 10K ohms. So we have 10.6 divided by 10,000. I got 1.06 milliamps. 1.06 milliamps. Good. Okay, let's do problem 10. A minor stinker, but we'll handle it. Okay, our diode is forward biased, so we're going to get 0.7 volts. Which is the same as our diode, because it's in parallel to our other diode. So let's find the current of that. So IR2 is 0.7 volts divided by 2K ohms. So our current through that guy 0.7 divided by 2000. Current is 350 microvolt amps. Okay, good. So we have 0.7 here, which takes away from our, so our R1 voltage equals 10 volts minus 0.7. 9.3 volts. So our current in our 1K equals 9.3 volts divided by 1K equals 9.3 milliamps. Okay, so our total circuit is, okay, we have 9.3, okay, let's do IT, equals 9.3 milliamps plus 0.35 milliamps. Let's move it over 3 decimal places, equals 9.65 milliamps. That's our total current. Our current through our first resistor, 9.3. And our current through our diode is going to subtract those two. So we got 9.3 minus 0.35, 8.95, so milliamps. Okay, let's design a LED circuit. And our LED voltage is going to be 1.5. Alright, so we have our total voltage across our diode is going to be 5 volts minus 1.5 equals 3.5. Okay, so we have 3.5 and we want a current of 20 milliamps, so we need to find R. R equals, okay, let's just do V equals IR. And we want R equals V over I. So we have 3.5 volts divided by 20 milliamps. So our resistor size is going to be 3.5 divided by 20 second E minus 3, and I got 175 ohms, which sounds very reasonable for a diode.